If you want to provide a simple interface that controls a complex system, the Facade design pattern is a great choice, if you do it right. But how does it work, and what are the limitations? One limitation is that if you suggest using the pattern to someone that doesn't know it, you sound like a snob. Facade? Facade? Other than that, it's great. If you really want to come off as a snob, you should watch my free workshop on code diagnosis. ArjanCodes/diagnosis to get access. If you follow the 3-factor framework that I show you in the workshop, you'll be able to completely demolish any piece of code. Can you please increase the font size in your IDE? It's too small to read from the high horse that I'm sitting on. Anyway, arjan.code/diagnosis to get access for free. Other developers are going to love you. Really. I'm going to be using an Internet of Things example here. So this is a simple application that allows me to create Internet of Things smart devices. When I run this, it opens an application. It has 2 buttons. I have a speaker off button, and when I click that, then it switches to speaker on, so I can use this to power on or off a speaker. You see it logs some messages like what speaker I'm toggling, connecting to the IP address, sending some data, etc., etc. And there's a status update button. When I click this, it's going to retrieve status information from each of the devices that are connected to this application. Now, this is not a real application. All of this stuff I just made up. So there's no real smart devices here, but it's just to show you as an example. So it uses tkinter to create this user interface, and you see that I rely on an IoT package that contains things like devices, services, sending messages, connecting to a network, etc., etc. So this is the file structure. You see we have these 3 folders here. Internet of Things that contains devices like the smart speaker that I used in the example, but there's a couple of other ones as well. And then there is a service that manages all these different devices. We have a message type that has a sender, receiver, some content. Messages are sent over this network in a base 64 format. All this stuff is not really important. It's just the idea that we have some complexity in the example. And then there's also a network connection object, which has connecting, disconnecting, that's a host and a port. If you look at the main file though, which contains the GUI specification as well as all this interaction with the Internet of Things devices, fake devices, then you see we have in the initializer, we create a service, then we create the smart speaker, then we create the user interface, which is pretty simple. It's just a couple of buttons and a status label that contains status information. Then we have a toggle method that logs some info. So this toggles the speaker power. And then what it does is, well, it changes the text of the button, but then it also creates a connection to the smart speaker by getting the device first, retrieving the connection info, creating the connection object, then constructing a message, and then sending the message over the connection as a B64 string, and then it logs again something that we're done. Similarly, we have display status that also goes through the devices in the service and then adds status information and then prints that in the interface, and then it logs some extra info as well. And then there's a main function that simply creates a smart app instance and starts the main loop. And there's some logging initialization. There's several problems with how this is being implemented. One is that the GUI needs to know lots of implementation details about the Internet of Things service. It needs to know that there's a service, that it needs to create a smart speaker device. It needs to know all kinds of low-level connection information, and that's not great. Another issue is that currently everything is in one big class that's responsible for both GUI things and for business logic things. And that's also not really nice. The class has low cohesion. It tries to do too many things at the same time. So it's helpful to split this up a bit, which I'm also going to do in this video. But most importantly, if you want to decouple the low-level things like Internet of Things services and connection objects from your actual application, then the Facade pattern is a really nice way to do that. The Facade design pattern helps by introducing an object that sits between your low-level system and your application code. The object defines a simplified interface to that lower-level system so that your code is no longer coupled to low-level things. Facade often hides some concepts and simplifies others. Here's a class diagram that illustrates the pattern. The facade hides the various classes to the client, and the client uses the much simplified interface of the facade. In the Internet of Things example, we can use Facade to decouple the GUI from the lower-level Internet of Things system. However, there's a problem. At the moment, the GUI class basically contains everything, which means it has low cohesion. It has way too many different responsibilities. It's better to let the GUI focus on user interface things and move the logic somewhere else. So let's start with improving that. But before I do, if you enjoyed the video so far, give the like. It's going to help other people find my content, which brings me closer to becoming an evil software development overlord on YouTube. You didn't hear that last part. The first thing that I'm going to do is split the GUI code from the business logic code. And the way to do that is by introducing something called a controller. And what I'm actually implementing then is the architectural design pattern called Model View Controller. Model stands for data, view stands for the GUI, and controller stands for the business logic. Now, in this example, we don't really need a model because we don't really have any data. Though technically speaking, you could consider the whole Internet of Things connection layer the data, because that does store some status information about those objects. But I'm going to concentrate on splitting the view and the controller here. You can decide to use a purely object-oriented approach here and have the controller be an object of a particular class. But what I'm going to do in this case is simply define two functions. One to handle powering the speaker and one to handle retrieving status information. So the first thing that I'm going to do is, instead of putting everything in one main file, I'm going to create a main file and a GUI file. So I'm going to rename this to GUI.py because it contains already most of the GUI stuff. But then I'm going to add another file called main.py. And then what I'm going to do is I'm going to take this part, the whole main part, and I'm going to put it in the main file, like so. And now, of course, I also need some imports, like logging. So I also need to put that here. And of course, I'm going to need to import the smart app. So that's automatically imported, like so. And then we have our basic main file. And now I can remove this from this file, like so, and I still need all of the imports that I have here. So that's already something. We have a GUI and we have a main file. Now, the next thing that I want to do is split out the business logic. And the business logic, that's basically the initialization code here. It's the toggle behavior, all this low-level stuff that we have here. And finally, it's the displaying status information here, especially the part where we retrieve that information from the Internet of Things service. Basically, what I want to achieve is that I remove these low-level imports from my GUI object so that the GUI is not concerned with that anymore. So let's create a new file here called IoT controller.py, like so. And that's where we're going to put the controller functions. So what I'll do to get started is take these two methods and I'm going to copy them, and then I'm going to refactor them so that they do something slightly different. So let me de-indent this code, like so. And now, of course, I'm going to need some imports, like logging. Now let's think about how we want to structure these controller functions. So one thing is that they're going to need access to the Internet of Things service. And of course, it's no longer part of an object. So what we can do is instead pass it as an argument to each of these functions. So instead of calling this toggle, let's call this power speaker. And we're going to provide it with a service, which is an Internet of Things service object. I need to type that correctly, of course. And then let's also import that. There we go. Now, instead of using self.service, I'm simply going to use service. What I also need is the connection object. And apparently there are lots of different connection objects, but I want the one from network.connection. Like so. I'm going to need a couple of other things as well, like the ID of the speaker. So let's also add that as an argument. And that's a string. And now instead of self.speaker_id, I'm simply referring to the argument. And then I can remove those parts here like so. We also need the message class. So from message.helper import message. And I'm using MSG, it's a bit shorter as an alias here. So then this is what we get. There's also still some GUI stuff here in Power Speaker, like this, for example. So this we need to remove here because that still belongs in the GUI. So I'm simply going to remove that. Also, we don't have speaker on because that's an instance variable of the GUI. So what we can do is pass another argument here, which is whether we want to power the speaker on or off. Then this we can delete. And what we can do then is construct the message before so that we can also log it. So here I'm going to define the message, which is switch on if on, else switch off. And then I can create a logging message here. For example, sending message to speaker, and then I'm giving the speaker ID, and the status is going to be message, like so. Let's add a point at the end. So then this stays the same. We still have a speaker IP and a speaker port, and we use the service to get the device. We create the connection, and then we construct the message. And for that we need the server, speaker ID, and then we need the actual message, but we already defined that at the top, like so. Then finally we connect and send the message. And logging info here, we can also change that a bit to message sent to speaker. And then we're going to print the message once more, like so. So that's our Power Speaker function. Let's also refactor this function, and let's call that get status, because we're not displaying here, that's what we're doing in the GUI, but we're simply getting the status, and this is going to return a string. So we still have the logging info, and then we're going to construct the status string for each of the devices. So again, here we also need access to the service. So instead of self, we're going to pass here the service, which is an Internet of Things service instance. And then I'm going to remove the self here. So we're logging the status, and then this part, updating the label, that's part of what the GUI is supposed to do. But then in the end, we're going to return the status, like so. So this is our business logic. We've put that now in this single file, which is really nice. So how do we connect this to the GUI? Well, one thing you can do is that the GUI actually gets references to these functions that it then calls whenever you press a button. Almost like callback functions, actually. So let's go back to our GUI class, and then we have the smart app class. So the initializer, we're going to now add a couple of arguments here. And the first thing that we'll add is a power speaker function. So this is going to power the speaker, and that's going to be a callable, and we want that to be very simple. It just should get a Boolean value whether we want to power the speaker on or off, and then it's not going to return anything. Now that's not what our current power speaker function looks like because it expects extra information, but I'll show you how to deal with this in a minute. So another thing we're going to need is the get status function, and that's also a callable that doesn't get anything, and that's going to return a string. Also here doesn't match the controller function that we have, but we're going to fix that in a minute. So then what we'll do is store these things. So self.power speaker function equals the value of the argument, and self.get status function as well. So now we have access to this in the rest of the code. This part, that's initialization code, shouldn't be in the GUI. So I'm going to remove this, and I'm going to put this in the main file. So this is where we'll now create the Internet of Things service, and that's not self. We're going to turn that into a local variable, and same here. So we have a speaker ID that we register, and then here, of course, we need access to these things. So we're going to import them like so. Let me save this. I'll continue working in the main file in a minute. Let's first fix the GUI. So we have stored these functions. Create UI, we don't have to change anything. But now in the toggle method, we need to change things because of course this we're not going to do here anymore. So first let me remove the logging information because already that we're not going to do. This we still need to do because we still want to switch the speaker status here and keep track of it in the GUI because we need to display the right text on the button. So that's what we're doing here. You can probably avoid using this variable, by the way, if you just read the text from the button, but I think that's not really clean. I think this works a bit better. So these things we still need to do here, but what we can do now is call the power speaker function and simply pass it the Boolean variable, which is self.speaker on. And then the rest we can simply delete because our controller is going to handle that, which we still need to connect to the GUI. Display status, very similar. So we're not going to do logging anymore, but what we're going to do is status. We're going to use self.getStatus function. So now we have the status, and then we can simply display the status on the label. And logging we also no longer do here. So that turns display status into a 2-line method. So this is good. Our GUI is now a lot more compact. And there's also a couple of imports that we can now remove. As you can see, logging no longer needed. And we're also no longer dependent on any of these low-level things that we depended on before. So let me just remove all of that, and that considerably simplifies the GUI class. Now the only thing we need to do still is make the connection here. So Smart App is going to expect 2 functions from us, but the controller functions are not exactly what we want them to be, because they expect the service and the speaker ID, and the GUI can't deal with that because it doesn't know about those things. A nice thing that we can do is use partial function applications to create functions that match what the GUI expects. For example, the power speaker function, we can use partial from functools to create a new version of our original controller function. So that's power speaker, which we import from the controller file. But then, and this is what partial does, it allows you to supply arguments to a function that creates a new function where those arguments are already applied. We can apply the arguments service, which is going to be our service that we defined in the main function right here. And we're going to supply the speaker ID. And this is nice now, because now power speaker function is a new function that only expects a Boolean, because the other 2 arguments have already been applied. So this is exactly what the GUI needs. We can do the same thing for the getStatus function. So that's also a partial application of getStatus. And here we simply supply the service, like so. So those are the 2 functions that we're going to need, and now we can simply pass them to the application. So we have power speaker function and we have get status function, like so. So let's run this code and see what's happening. So again, it has exactly the same behavior, but now we've split up the code a bit more. Status update also still works as expected. So this already helps a lot. Instead of 1 file, we now have 3 files. The main file, which is relatively short, that creates the things. We have the GUI, which is now pretty separate from the rest of the code. It only knows about controller functions that it's going to call, like power speaker and get status. And we have the controller that defines what actually needs to happen. So it does help, but it still doesn't solve all of the problems, because the main function still needs to know implementation details of the Internet of Things system. It needs to know that there's a smart speaker device, that it needs to register, that there's a service, etc., etc. And the controller, that's of course still the same problem. We simply moved our low-level things to another layer. So if, let's say, we want to extend this application later in the future by adding more facilities, like maybe we want to add extra devices that we want to control from the interface, well, then we need to copy a lot of this low-level code, and we have to deal with that ourselves in the controller functions, which is not ideal. And you can create helper functions, but it's still going to be coupled to the low-level Internet of Things system. With the facade pattern, you create a layer that hides a lot of these things to the rest of the application, which is why the pattern is so useful. It really provides a strong way of decoupling your code. So let's use the facade pattern to provide a layer so that the GUI and the controller functions don't need to know anything about low-level Internet of Things. Internet of Things. That's weird. Okay. So what I'm going to do is create a new file, Internet of Things Facade. And this is going to provide the layer between the GUI and the low-level Internet of Things service. So I am going to use class for this. Let's call that IoT Facade. That's going to provide the separation. And what that has is an initializer. And here in the initializer, we're going to do the things that we did in the main file. Now, if we want to keep this kind of clean, we should probably still create the service in the main file so that if we want to test the facade, we don't have to patch the service. If you want to completely separate this, you could still create a separate function that creates a service and then a facade object and then passes the service to it. But for simplicity, I'm not going to do this here. This is simply going to get a Internet of Things service that, of course, we need to import here. And then I'm going to store that as an instance variable, like so. And now what we do is we take the initialization code here, like creating the smart speaker and registering it as a device in the service, and do that in the facade so that we don't need to do it in the main function anymore. So that's this part. So I'm copying this over. So here I'm creating a smart speaker device that I'm also going to import here. And then I have the speaker ID that I'm going to need to store as an instance variable, like so. Then the second thing that I'm going to do is to move a lot of the Internet of Things low-level stuff from the controller to the facade, so the controller doesn't have to deal with that anymore. So again, let me just copy these two functions because they contain a lot of that detail, and then move it here, and then I'm going to refactor it. So I'm assuming that the logging part is not something we want to do here, but that's still something we will do in the controller, because this is just the interface to the Internet of Things layer. So I'm going to remove the logging information here. So now we have a power speaker, and that's going to be a method, so it needs self, obviously, and these things are not needed because they're part of the class. And then this again becomes self.service, self.speaker_id, and we're going to create a connection, which again I need to import from network.connection. There we go. And also the message helper, obviously. Like so, and then this all remains the same. Get status doesn't get a service, but uses self.service, and that's all it does. So this is basically the interface to the whole Internet of Things system. And as you can see, the facade now provides a simplified interface to this whole layer by having a power speaker method and having a get status method. It's not the most generic way of setting up a facade. Maybe you want to have something that supports generic message sending if you want to support lots of different devices. It's not really the goal of the video today, just want to keep it simple. Now the controller becomes also a lot simpler, of course, because it's only responsible now for logging things, and then it can simply call the facade methods. So what we can change now is that power speaker doesn't get service and speaker IDs anymore because it is not concerned with that, but it gets a facade object. There we go. And then let's also change the logging info, powering speaker, and then it prints the on/off status, like so. And then what it's going to do, it's very simple. It's simply going to call IoT.powerSpeaker, and it's going to pass the on value. And then this we can delete. And the only thing we do is we keep the logging messages. And here we simply write message sent to speaker because we're logging here on a higher level. So the F is also no longer needed. So that's power speaker. Then get status is very similar. We don't get an Internet of Things service. We get the facade. And then we're going to use .get status from the facade. We log the info and we return the result. So that's get status. Now you could decide to move all of this actually directly to the GUI, but I'm keeping it separate here in a controller function because then maybe you want to add other things like other types of logging, emailing, whatever. And then that part is separate from the lower level Internet of Things service. So how do we change the main file now? Well, we still need to create the Internet of Things service because the facade expects that. But then as a next step, we're going to create the facade. Like so, and we need to pass it the service. There we go. And now we don't need to create the smart speaker anymore. We don't need to register the device because the facade takes care of that. And it also means that coupling the GUI with the controller function now becomes much simpler because the power speaker function that expects now the Internet of Things facade, like so, and get status very similar. So then this is what we get. So we have the facade that hides lower level concepts from our application, like smart speaker device and network connections and things like that. We have the controller that separates the behavior, which is logging and controlling the Internet of Things device, from the GUI, and the GUI simply gets controller functions. So now things are nice and cleanly separated. And you'll see in the main function, if we scroll up, that, well, a lot of these low-level things, we're not going to need them anymore because we simply rely on the controller and the facade. Again, the service is still here because we are patching everything up in the main function, but you can also decide to split that out if you want to really keep it separate. So let's run this one more time, and you see we get exactly the same effect, the same results as we had before. So as you can see, facade works well with an architectural pattern like model view controller. If you want to learn more about software architecture in general and the model view controller pattern, check out this video where I show you an example of how to set that up. So there's a few interesting things to note. First, since I'm already using a controller, I didn't need to update the GUI class at all, since that relies on the controller only. That shows us one of the advantages of splitting the view from the model and the controller. If something changes, it'll probably be less work to update your code. Second, the only place where I'm still referring to low-level Internet of Things code is in the facade class and in the main file to patch things up. The rest of the application is decoupled. The main function creates the facade object and uses partial function application to create the controller functions. An alternative thing you can do is create a controller object that gets a facade in its initializer, and then the controller functions will be methods of that class. It achieves the same thing. I slightly prefer to do it with partial, since you don't need an additional object. And you have a bit more flexibility in that you can decide to move some of the controller functions to different files, which you can easily do with the class. If you want to completely decouple your application code from lower-level Internet of Things code, you could decide to let the facade create the Internet of Things service object. You can then also remove the dependency from the main file. However, this would make testing the facade a bit harder because you would have to patch the service object. One thing you could do is create a separate helper function that creates the Internet of Things service object for you and then also creates the facade. Then at least you've still separated creation from use, but you don't have to worry about that in the main file. When you want to extend the code in the future to have more functionalities, you might have to extend the facade as well to support it. This is one of the disadvantages of the facade. Since it's a simplified interface to the lower-level system, it may need to be modified so that new features can be supported. It's always a balance. However, the interaction with the low-level system is centralized in facade, making this a much easier job than when everything is coupled like in the original version of the code. I hope you enjoyed this video. As you've seen, the facade is really helpful in reducing coupling. And this helps your code become a lot easier to manage. If you'd like to see more ways to reduce coupling in your code, check out this video next. Thanks for watching and take care.